Methods of separation. Separation of salts, energetics, barium nitrate sulfites, crush measure tools, control, repeat conclusion, memorize lab equipment, salt prep by neutralization. Titration, wash burette with water, then with solution. Repeat, eliminate errors, take average and compare, using polystyrene and lid. Describe how to carry out a flame test. Use a clean platinum wire, put the sample on the wire, and place it in a blue roaring flame of Bunsen burner. How do we clean the wire? Dip it in HCl. Why do we clean the wire? To remove any previous chemicals or impurities that might be left on the wire. Chromatography ink on baseline. Solvent level on paper. Draw baseline with pencil. Temperatures drop to room temp. Questions 2023, 2024 Q&2. Accuracy improvements. Insulating. Explain why the results of the experiment are more accurate if the boiling tube is wrapped in cotton wool. Insulator. So reduces, prevents heat loss, traps heat. Temperature more accurate, does not cool down, prevents temperature decreasing. Explain why using a polystyrene cup in place of the glass beaker would increase the accuracy of the results. Insulation, stops temperature going up, or prevents heat loss, prevents heat gain, prevents energy exchange with surroundings. Stops temperature going up, reduces increase in temperature after reaction has ended. Explain why wrapping the beaker in cotton wool after it has been heated will improve the accuracy of the results obtained. M1 insulation reduces heat loss. M2 temperature remains more constant, changes less, does not change, is maintained. Why is using a metal container not an improvement? Conductor increases heat loss gain. Measuring. Describe one way in which the results of experiments 1 and 2 could be made more accurate. Repeat and find mean or use a burette in place of measuring cylinder. Explain why it would be an improvement to measure the volume in a burette rather than a measuring cylinder. Burette. More accurate than a measuring cylinder. Suggest why it would not be an improvement to use a pipette. Slow to add. Explain why it is not possible to use a volumetric pipette to measure. Volume used is not fixed. Salt prep. Describe what the student must do after filtering to obtain dry crystals of pure sodium chloride. Heat. To point of crystallization. Dry crystals with filter paper. Explain why the rock salt is made into smaller pieces to speed up the dissolving. Mixing. State why the conical flask is swirled as solution F is added in experiment 1. To mix. Reactants. Suggest why the solid sodium carbonate and solid citric acid are stirred before the temperature is measured. So that the sodium carbonate mix together, so they react, so the temperature is the same throughout the mixture. Rinsing. In experiment 2, the burette and the conical flask are both rinsed with water. The burette is then rinsed with solution B. State why both the burette and the conical flask are rinsed with water. Explain why the burette is then rinsed with solution B. To clean, remove solution A. To remove water. Suggest why the conical flask is rinsed with distilled water. To clean, remove substances left from experiment 1. The conical flask is not dried after it is rinsed with distilled water. Suggest why the conical flask is not dried. Does not change amount moles of sodium hydroxide. Repeat. Suggest how the reliability of the results from experiment 1 and experiment 2 can be confirmed. Repeat and compare. Describe one way in which the results of experiments 1 and 2 could be made more accurate. Repeat and find mean average or use a burette in place of measuring cylinder. Heat. Describe how the apparatus could be altered to minimize the change in temperature. Stand flask in a water bath. At initial temperature of the acid. Explain why the temperature change was smallest in the experiment largest volume being heated. State whether the reaction is exothermic or endothermic. Endothermic, and because the temperature decreased. Exothermic, and because the temperature increased. State the effect, if any, on the volume of dilute hydrochloric acid used in experiment 1 if the solution of sodium hydroxide is warmed before adding the dilute hydrochloric acid. Give a reason for your answer. Effect on volume. No effect. Reason: temperature does not change the amount of sodium hydroxide present when gases. The waste gases contain methane. State why the waste gases should not be released into the laboratory. Methane is flammable. The waste gases contain CO. State why the waste gases should not be released into the laboratory. CO is toxic. The waste gases contain ammonia. State why the waste gases should not be released into the laboratory. Ammonia is toxic. Rate of reaction experiment. Describe how the results of the experiment would change when the experiment is repeated using a 250 cubic centimeters beaker in place of the 100 cubic centimeters beaker. Explain your answer. M, 1 time shorter decrease. M, 2 less depth to look through. Suggest why the conical flask is placed on black or dark-colored paper in experiments 1 and 2. White, precipitate cloudiness easier to see. Titration. Explain why the student adds an indicator so that it can change color at the end point. Describe how the student can determine the volume of dilute hydrochloric acid used in this titration. Take initial and final Barrett readings. Final reading minus initial reading. State which solution is the more concentrated. Explain solution A and greater volume of acid was used in the titration. State the volume of hydrochloric acid needed if experiment 1 is repeated using 10 cubic centimeters of solution. Remember to include units. Explain what happens at the point labeled by ice cools. Steam vapor gas. Steam vapor gas condenses water, collects forms. Add hot water to the sugar cane and stir to dissolve the sugar in the sugar cane. Explain why hot water rather than cold water is used. Fermentation.